With their eyes set on the future of beyond visual line of sight aircrafts, this company is developing technology that will enable safe airspace integration for any aircraft. Let me introduce Sagetech Avionics. Hello everyone, welcome to another episode of Builder Nation. Today we are joined by Tom Furey, CEO at Sagetech Avionics. Tom, welcome. Thank you very much for joining us today. Could you please introduce yourself a little bit?
Sam, hi. Sure, it's my pleasure. My name is Tom Furey. I'm the CEO of Sagetech Avionics. I've been with us since we started, which was about 3.5 years ago. We were actually a unique startup, so we carved out or bought assets from another company called Sagetech Corporation. And before that, I had a career that started with flying aircraft in the Navy, which began my love of aviation and all things that fly. And then I've been in a variety of different industries since then before coming to what was Sagetech Corporation about 8.5 years ago. And here we are today.
And here we are today indeed. Thank you very much for that. I took a look into your history and your preparation. You are an engineer, you have preparation in finance, and you have a lot of experience leading operations teams, right?
Right.
You're the trifecta. What skills have you brought into specifically Sagetech? How have you been able to escalate this company from a startup to right now where you have over 30 employees?
I don't know that it's me so much as the team, but maybe that's part of what I've brought to it. So for one, as you mentioned, I do have an engineering background. I've got a few engineering degrees. I've got a background in flying aircraft. I've got a background in manufacturing. And really what all of that comes together is it helps me as the CEO be able to provide enough intelligence to guide our tech team, but they're the experts in developing our products, et cetera. I have enough to understand how we can manufacture our own products. A jack of all trades, master of none, if you will, but enough broad-based background to kind of keep everything together, understand where we need to focus, understand when we have something going off the rails, how we can resolve those issues, and help our team see what the best opportunities are in the aerospace market as well.
Actually, that's perhaps a quick question. What caused you to go from actually manned aircrafts, which are the one you actually flown, to these unmanned aircrafts, drones? What made you jump from one to the other?
Yeah, first of all, it was an opportunity. As I mentioned, I started as the chief operating officer for a company called Sagetech Corporation. That company did a variety of different things for unmanned aircraft. And then it struggled and the owner decided to get out of the business. So a bunch of us that were in there recognized a part of what we were doing there as really vital for the success of unmanned aircraft later on. Now, from my perspective, it's funny, I think there's so much opportunity for unmanned aircraft and other future aircraft, not just unmanned, right? But eVTOL aircraft, still be piloted, but unique aircraft configurations that we're starting to see with electric and hybrid hydrogen propulsion and other things like that. All of this is really changing the face of airspace. When I flew an aircraft that was designed in the late 1950s, and I flew off of aircraft carriers and we dropped bombs, but not only did we drop bombs, sometimes we just drilled around in circles and literally you've got a multi-million-dollar aircraft. You've got a crew of 2 people holding in circles, getting ready to give fuel to other aircraft, right? That's something that you don't need me in the cockpit to do. And lo and behold, we've talked to companies that are making things that are the future unmanned aircraft for the Navy to provide fuel to manned aircraft, right? So it's recognizing that there are reasons that you need a human in the cockpit. There are reasons you need a human in the loop. And there are reasons that you should put people in harm's way, which anytime you're flying, you're taking your life in your hands. But there are many reasons why you should. And unmanned aviation gives us the ability to utilize the third dimension, utilize air without putting people at risk, taking advantage of autonomy and artificial intelligence and all the other things that in some cases can make a machine do something better than a human can. And I think we're right at that turning point right now where we're starting to recognize where humans in aviation have their place and machines alone in aviation have their place. When I flew, Sam, we used a thing called an IFF. So it was a military jet. And the IFF is what identifies friend or foe to other allied people. It's a military version of a transponder. And the thing was the size of a cinder block, weighed about 15 pounds. Now we are making the exact same thing that can be used in crewed or uncrewed aircraft. And we're doing it this big, the size of a deck of cards. That's what excites me. We're able to take that same capability that manned aviation has enjoyed for decades and miniaturize it in such a way that it's just as capable, just as secure, but it enables very small aircraft or very low power aircraft to perform the same missions with the same level of safety. So that was a long answer to a short question. That's how I got to know.
No, it's amazing. Thank you very much for that. Actually, out of that reply, I have 2 questions. Number one, you mentioned that Sagetech Corporation was getting out of the business, right? What caused the whole team to focus on something such as specific as the transponders?
So we had within Sagetech Corporation, the transponders and the other avionics, which we're now expanding beyond transponders, were a portion of what we did, but it was diluted by the fact that we were trying to do a lot of other things. That company was involved in composites manufacturing, was involved in electronics testing, you name it. And it was dedicated to certain lines of business that ended up struggling. But a few of us inside the company, we started out with 12 of us that came out from that company and formed the new company. And as you mentioned, now we're up to about 30. So we've attracted other people. But we recognized that the transponders that we were creating in Sagetech Corporation, they weren't certified, but they were, I love show and tell.
I love seeing this.
They were even a little smaller, right? It was the first micro transponder. So this was the first time that we brought that shoebox size or cinder block size capability to enable unmanned aircraft to be as visible and safe in airspace as manned aircraft. But we recognized that the world of unmanned aviation at that point, a few years ago, was changing from the Wild West, where drones were mainly used by the military and there weren't a lot of regulations around them, et cetera. But it's becoming a more integral part of aerospace. And we saw that while this product may not last forever, and in fact, we still sell some today, but certified products that enable safe integration in a reliable way could be created from that same technology to enable unmanned aircraft to basically plug and play into the same airspace structure that manned aircraft have enjoyed for generations. So a few of us saw that there was a real opportunity there to leverage that technology to help enable the future of unmanned aviation. And that's why we all got together and said, let's take this piece of this company and make it into something special.
That's actually amazing. Now, I want to jump back to the second question that I had. You mentioned that you focused on miniaturizing these transponders that were these huge, large devices, right?
Yeah.
Now, did you actually work on creating your own from scratch? I understand miniaturization of hardware is an extremely complicated task. So how did you actually come to, how long did it take you to arrive where you are?
As I mentioned, we came from this company, right? And this company developed this in 2010 and it was released in 2011. And it's fairly miniature, as you can tell, but it's not quite robust enough to get certified by the FAA, to get the encryption stuff certified by the Department of Defense. So what we did was leverage the work that we had already been doing inside Sagetech Corporation and evolve that to be a lot more disciplined in making something certifiable. When you do something that's certified for aerospace with reliability of safety, 1 × 10⁹ probability of failure, right? You've got to start from scratch. So we started from scratch, but with all the learnings we had here, a blank sheet of paper. And our products, I like to say we're really good developers, but we're not inventors, right? So we didn't invent some new way to enable aircraft to see each other in airspace. We didn't invent some new substrate to be used in a transponder. We took commercial off-the-shelf hardware. We took the smallest, lightest, lowest cost that we could that met the rigorous technical requirements we had. And what I like to say is our engineers bend the rules of physics, right? So there are certain things when you're building a circuit card that your manufacturers that have been doing this forever, that are making shoebox or cinder block size hardware, they restrict themselves by looking at trace widths and how close they can put things together and where you can put a 500-watt amplifier next to a very sensitive receiver. And they say you can't do that thing because it hasn't been done that way in the past. And we throw that out the window. We look at a circuit card and see how much we can smush in a single place and then say, now how can we make this work? How can we isolate the circuits, or how can we use a smaller component, or how can we make something a little bit more flexible to transmit and receive on different frequencies, et cetera. And when I say we bend the laws of physics, we can't change the laws of physics, but we can look and see what's been acceptable and what is the art of possible. So can we do this with a smaller trace width? Can we put things closer together? We try it, we test it, we see what we've got. Because we start with a blank sheet of paper that's this big, we begrudgingly make it larger, right? And I think other companies who have been around forever start with a motherboard design that's this big and say, now, how can I shrink that? And they run into their own natural innovation limitations. And we don't do that. We start small and begrudgingly get larger. So I would say that's our engineering philosophy that has helped us create technology in a very small way that maybe hasn't been done like that before.
I have to say, it is a very unique approach. So thank you very much for sharing with us that. Now, I believe it would be wise to pull our houses a little bit. And for all of us who might not really be familiar how transponders work in aircraft, can you please explain us the overview?
We become transponder geeks and then forget that's not something that other people do. As I mentioned, we make and sell transponders, and we also make collision avoidance systems, and those are related technologies. So a transponder is essentially, to get a little technical, right? A transceiver is something that receives and transmits on the same frequency. A transponder receives and transmits on a different frequency. And all aviation transponders around the world use the same frequencies. And what it does is, picture you're flying over Los Angeles in an aircraft, and air traffic control sees you on radar. Well, all radar can tell you is it puts a blip. It says, at this bearing, at this range, there's a thing, right? And it doesn't know anything else. The technology was actually started by the Brits back in World War II, but they said, let's try and find out more about this. And they did some unique things with it so they could tell whether it was their boys coming home or whether it was Germans coming to bomb them. That has evolved to now where an air traffic control center or LA center or something like that will interrogate. It'll send out an RF signal on a certain frequency, and the transponders in the aircraft will automatically receive that and will answer. And basically what it's doing is, when you have radar that says range and bearing, now the transponder is answering questions about who am I, what's my call sign, what altitude am I at, what's my heading, what's my airspeed, what's my latitude, my longitude, all that other information you might need to now provide a better air traffic control picture. The other thing is there's a thing called ADS-B. So those are different transponder modes, and those are different types of questions, the different modes, mode A, mode C, mode S. Those are different types of questions that are asked by, say, an air traffic controller to an airplane, and it's all automatic, right? But the transponder responds. ADS-B then broadcasts that information continuously, and now you can put a receiver in another aircraft so it can receive information about all the other airplanes around it. So now he's not relying on the air traffic controller to tell him what traffic is around him and to deconflict it. He can see what traffic is around him himself and deconflict. And that's the foundation for a collision avoidance, which then is an even smaller little box. It takes the received signals from the transponder and then puts all that together with maybe an air-to-air radar or a vision system, a camera system or something like that. It's sensing all the traffic around it, whether that other traffic has transponders or not. It's building an air picture, determining whether there's a risk of collision. And if there is, it's using prescribed maneuvers to avoid that collision, so that now an aircraft, an unmanned aircraft, can fly out beyond line of sight, can on its own sense all of the other aircraft or detect all of the other aircraft around it. We call it detect and avoid. So it can detect everything around it. And if there's a potential risk of collision, it provides the calculated avoidance maneuvers either to the operator or directly to the autopilot for that aircraft to avoid a collision with another aircraft. And that's what ADS-B is doing. It's telling everybody that you're there and allowing them to help avoid you.
That's amazing. And for your specific devices, did you build the software on your own? Is it in-house or is it shared so that anybody else can use it?
It's built on our own. So it's our own implementation of an FAA-sponsored algorithm. So ACAS-X is a family of collision avoidance algorithms which enable all types of aircraft, commercial aircraft, general aviation aircraft, business jets, eVTOL aircraft, small drones, large fixed-wings drones. There are versions of ACAS-X for all of those. And the FAA TCAS, Traffic Collision Avoidance Systems, program office, sponsored through researchers at MIT Lincoln Labs and Johns Hopkins Applied Physics Lab. They've created these robust algorithms for how to recognize a potential collision and how to avoid it. And then, of course, they do it in academic world where you can have tons of computing power and everything at your thing. So then our challenge is taking those algorithms and miniaturizing them in a way that can be done in very low size, weight, and power with minimal memory constraints. It can be done very reliably, etc. It's not necessarily open source, what we provide, but it's an implementation of that ACAS. But then we try and make it to where our algorithm and our collision avoidance computer is agnostic to the types of sensors. And what I mean there is this will have baked into it the ADS-B receivers that I mentioned to receive other cooperative traffic, it's called. Other aircraft that have transponders have ADS-B, that's called cooperative traffic. But then there's non-cooperative traffic. It doesn't mean they're illegal. It means they're just not using those same ADS-B or transponder frequencies. So maybe that's a paraglider. Maybe it's somebody flying their Cessna under visual flight rules, not under air traffic control. They're there, they're allowed to be there, but they're not using ADS-B signals. So you have to use non-cooperative sensing like a radar, like a camera system, etc. And we're not that sensor provider, right? We're making this so that any customer who puts this on their airplane can plug and play whatever makes sense to them. They can plug in a certain vision system, they can plug in a radar system or other non-cooperative sensors to work with our cooperative sensing and then collision avoidance algorithm to provide then the collision avoidance maneuvers, to provide safety, to prove to the FAA that this airplane should be allowed to fly beyond line of sight of its operator.
Okay, that is quite insightful. Very recently, like 2 or 3 weeks ago, tops, you shared on your website that you got a certificate for a Mode S microtransponder. Could you please talk to us a little bit more about that?
Sure. Actually, that was a year ago. It remains active on our website. But that was this transponder, which is the MXS. And we talked briefly, Sam, about transponders, what they do, right? We've got 3 FAA TSOs, technical standard orders, so authorized. Basically what that says, if there's certain requirements to fly in airspace, which all manned aircraft and most unmanned aircraft will, but the rules are clear for manned aircraft flying in certain operations, CONOPS, concept of operations, require a transponder. This has the TSOs for a Mode S, and that basically says the FAA has already authorized us to put the TSO stamp so that now if an aircraft manufacturer is going for an aircraft approval, the FAA doesn't need to see the details of this. It's already got the check in the block. It's an approved component, a subsystem on their manned or unmanned aircraft towards certification. So what was unique about this, first of all, obviously it's very small, but it was the very first small transponder that was certified by the FAA, which includes ADS-B transmitter and receiver that are both certified. So I mentioned that ADS-B receiver, and especially the certification, to be able to discern lots of different aircraft in crowded airspace is a technical challenge. To get certified in that in this small box means now if we put this on an aircraft that can not only identify itself, it can see, or it can be seen in airspace, but it can see all the other aircraft with that ADS-B receiver. And that's a vital part of its ability to fly beyond visual line of sight.
It's honestly amazing. Congratulations on being the first to achieve that milestone. Now, I want to move very quickly into another aspect of your job, which is your part as a CEO, right? Your company right now has defense, civil, and commercial solutions. How different is the product market fit from one another?
They're very similar, right? And the reason is because the Department of Defense recognizes, and this may be changed over the past, call it 10 years or so, right? The Department of Defense used to spend a lot of money researching and developing their own stuff or having companies do it specifically for defense. And meanwhile, the commercial market is moving a lot faster, right? It's more innovative, etc. So the Department of Defense recognized that, hey, we need to get on that train. So let's look for dual use technologies. And the way we provide those are, like I said, they're similar but different. So take this, for example. I mentioned the TSOs that we received last year. So this is an FAA certified product that has Mode S, ADS-B in and out, and also an altitude encoder. It senses the pressure of the airplane and determines its altitude. A military aircraft needs that same information, needs that same capability, right? But it also has a mode for NATO and allied forces called Identify Friend or Foe, which is essentially encrypted Mode S and ADS-B, right? But that is not something that is authorized for use outside of the military, the US DoD, NATO, or our other allies, right? So what we've done is taken this same exact hardware platform and created different software and firmware for it so that now it satisfies the military. So I can take the same platform and sell this to civil. The military version I can't sell to civil, and it also has ITAR export controls. It also has a sourcing component to it that I need to make sure I'm NDAA compliant, the National Defense Authorization, so that we have to look at our supply chain. And we do this for our own best interest as well, and make sure we have a robust and reliable supply chain, and that we're not buying parts from any, call it sketchy countries, where maybe it doesn't make sense for us to buy parts from there. And that's in line with the NDAA, but it also helps us be a good manufacturer and provider of products, even to the civil commercial markets.
I would not have guessed that the main difference relies on software rather than hardware. So thank you very much for that. Now, I want to jump and ask you about a little comment you made earlier in our conversation, which is that you are planning to expand beyond just these transponders that you built. So what is next for Sagetech?
What's next is this right here that I mentioned. We're currently developing, this is flying with certain customers. This is collision avoidance, ACAS X collision avoidance. And as I mentioned, right, if you use the transponder's ADS-B in and out, you can recognize you can see and therefore avoid most of the aircraft that are in airspace. But there's that other aspect of aircraft that aren't providing that ADS-B signal. So we are continuing to make ourselves compatible with off-the-shelf, manufactured by other companies' sensors, like different radar sensors and vision systems. This is where we're mostly focused right now, is on continuing to develop this. The FAA continues to evolve that ACAS family of algorithms I mentioned. We can implement that and then implement the sensor layers that integrate all of that. And there's all different versions. There's this size that weighs 2 ounces. And it is everything you need on a small drone, less than 55 pounds. It passively receives ADS-B signals. It can take ground-based information of other traffic or other onboard sensors and help that smaller drone avoid other aircraft. We are also integrating this directly into here, which then makes it a complete DAA system for larger drones, to where it receives ADS-B signals. It has to then interrogate those ADS-B signals as well, which is a little different functionality and a little different frequency use. But it does that because ADS-B is an unencrypted waveform and it can be easily spoofed. In other words, I'm not telling you to do this, but you could have an ADS-B transmitter on your desk that's pretending to be an aircraft out over Las Vegas, Nevada. If I happen to be flying over Las Vegas, Nevada and receive that signal, I might think there's an aircraft about to crash into me. While meanwhile, you're comfortably at your desk elsewhere. You're not really an aircraft. But if I interrogate it and measure some things about the time of flight, etc., I can determine that is a real ADS-B signal. So we've incorporated that into our transponder, and then we're incorporating the ACAS function. So now on an unmanned cargo rotorcraft, it can use the ACAS XR algorithm, and it can use just this box plus an appropriate sensor like a radar, etc., to have a full system. Also for flying taxis, even if they're piloted, this provides amazing pilot situational awareness. And we have it right on screens in front of the pilot or back on the ground station for a pilot in command, to provide them better ability to remain well clear of other aircraft and avoid collisions. And again, we're all about trying to avoid collisions in the air. We don't want any airplane swap and paint. We want to have lots of drones, lots of eVTOL flying taxis in the air, but we want to keep them all safe. And that's what we're focused on, is continuing to develop that technology so that people can put a very low cost, low size, low weight, low power consuming box on their aircraft that will help keep them safe against collisions.
And that's honestly amazing. Now, I just have one very quick question about this before we close our interview, which is, you mentioned that somebody could be on the table, have it open, and it might show up on a radar, for example, right? Is it possible for a transponder to actually emit altitudes?
Yeah, what it does, so this ADS-B signals that I mentioned, there are all the sort of different versions of an ADS-B signal, but basically you're broadcasting out there information about your airplane based on GPS, your heading, your airspeed, your altitude, your latitude, your longitude, so your position. So you're giving a 3D position. And I could literally right now transmit an ADS-B signal that says I am an aircraft flying over Greenland at 33,000 feet at 420 knots, headed 185, And if you're in the air and you receive that signal, now Greenland wouldn't make sense necessarily, but ADS-B signals have about 100 to 120 mile range. I could transmit something and say that I'm 100 miles from here at 15,000 feet and that not be true. And with an ADS-B signal, you wouldn't know that wasn't true. But if you interrogate it, measure the time of flight of that RF stuff, you can determine that's true or false.
Now, there is only one final question that I would like to ask you. As a CEO, as an expert in this technology, as an engineer, as a finance leader, you're like the whole package. Do you have any advice that you would like to give any young people starting their own path in engineering, in operations, in startups maybe?
My big advice is follow your passion, right? And especially if you're getting into the startup realm. And like you said, I don't claim to be an expert in any of those things, but I have to be the HR, I have to be the finance guy, I have to be the CEO, the visionary leader, all that kind of stuff in a small entrepreneurial business. Chances are you're going to have to do everything soup to nuts. I've even been known to clean the floors, right? So you got to do it all. If you're not wildly passionate about it, it gets to be painful and you're not going to put the energy, the time, and you're not going to put your best self in that. So love what you're doing or find a way to do what you love, and then becoming good enough at all different aspects of that and having the energy and passion to pursue it and be successful will come natural. So it's pursue what you love.
I believe that is the perfect way to close this out. Thank you very much, Tam, for being here. I'm sorry for those little extra minutes I hijacked, but appreciate a lot of your experience, your thoughts. We're going to find you. We're going to find Sagetech Avionics. Any social media handles?
We're mainly on LinkedIn. So Sagetech Avionics is on LinkedIn. Our website is www.sagetech.com. You can Google us. We're at any kind of unmanned systems or military trade show. Typically, if you're ever in the beautiful Columbia River Gorge in the Pacific Northwest, and you like to mountain bike and windsurf and hike and kayak, it's all right here outside our front door. So you can find us personally. You can find us virtually. You name it, we're around. If you Google it, you'll find us.
That is great. Thank you very much for that. Also, guys, remember you can find more information, interesting articles, and interviews directly on our website, controlhub.com/builder-nation. Thank you very much for hearing us. Thank you very much for being part of this community. Tom, appreciate a lot of your time. We're going to see you in the next episode.
Sam, thank you very much. It's been my pleasure. Appreciate it.